Steel gives a pipeline its strength, and coating gives it its life. In this video, we'll connect the dots between API 5L, the line pipe standard, and the NACE coating standards that keep that steel from ever seeing corrosion. API 5L is the governing standard for seamless and welded line pipe, defining its chemical makeup, mechanical strength, manufacturing process, and dimensional tolerances. Grades range from grade B to X120, each defined by yield strength, with two product specification levels, PSL1 and PSL2. PSL2 requires tighter chemistry, Charpy impact testing, non-destructive testing, and complete traceability. For coating inspectors and engineers, that traceability, the MTR, is your starting point, telling you exactly what steel you're about to protect. API 5L stops at the steel. It doesn't say a word about blast profiles, DFT, or holiday testing. That's where AMPP steps in with coating standards crucial for your work. NACE SP0394 covers plant-applied fusion bonded epoxy, SP0108 addresses field joint coatings, and SP0188 details holiday detection and testing. SP0169 focuses on corrosion control systems, and SP0178 specifies weld surface finish before coating. Together, these NACE standards pick up exactly where API 5L leaves off, forming the interface between structure and shield. API 5L controls the pipe's outside diameter and roundness, but for coatings, ovality and straightness determine how evenly fusion bonded epoxy goes on. A 20-inch pipe, even a 1/16th out of round, can produce thin film at the crown and thicker buildup at the spring line, leading to premature failure. API 5L defines the bevel and end finishing, while the coating spec defines cutback length, usually 2 to 3 inches for FBE. If these aren't coordinated, your field joint coating will either overlap too far or fall short, both causing problems. NACE SP0108 provides the playbook for handling those overlaps and tie-ins. Higher grade steels like X70 and X80 hold heat differently, which is critical during coating when the steel is preheated to around 430 degrees Fahrenheit for proper fusion. Too cold, the powder won't melt. Too hot, you'll overcure and lose adhesion. That precise temperature window is defined by NACE SP0394, not API 5L. API 5L pipe often arrives with mill oils and shop coatings, but NACE SP394 requires it to be blasted to a near white finish. This includes a 2.5 to 4.0 mil anchor pattern. Don't assume mill acceptance means ready to coat, as the coating line owns that surface. Weld seams, part of API 5L's manufacturing, create coating challenges because the crown of the weld can shadow powder spray. Once coated, verify continuity with a holiday test per NACE SP0188. Using about 125 volts per mil of coating thickness. A 10 mil coating should be tested around 12 and 50 volts. Finally, traceability, the MTR from API 5L should tie directly to your coating batch and QC reports. When you can connect a defect all the way back to a heat number and shift, you've achieved true quality control. Here's your quick reference map for core coating standards. SP0394 covers plant-applied FBE, specifying 12 to 16 mil dry film, 430 degrees Fahrenheit cure, and a 2.5 to 4.0 mil blast profile. SP0108 details field joint coatings requiring a 2 to 3 inch overlap and peel strength over 20 pounds per inch. SP0109 addresses field applied FBE repair, ensuring patches are within 2 mils of the parent coating. SP0188 outlines holiday testing, requiring 67.5 volts per mil and accepting 0 defects. SP0169 focuses on corrosion control and cathodic protection integration, while SP0178 covers weld preparation before coating. The most efficient projects write both API 5L and NACE specifications in the same breath. API 5L defines the pipe and NACE defines the protection. A good specification ties them together, like this example. This clarity eliminates 90% of coating disputes before they even start. Failures happen when the two standards aren't aligned. Oval pipe leads to thin DFT bands, dirty steel causes adhesion loss, and a wrong cutback results in bad field joint coating. Overheating creates brittle FBE, and no traceability means no accountability. Each one is avoidable when API 5L and NAC are treated as a system, not silos. API 5L gives you the backbone, and NACE gives you the armor. Together they make the line last a lifetime. For more training resources, visit Raphoon.com, where we turn coating standards into field-ready practice.